The population of a southern city follows the exponential law. If the population doubled in size over 28 months, and the current population is 40,000, what will the population be 3 years from now? So the exponential law that we're referring to is our exponential growth and decay model. And that is following the formula A of t equals A naught e to the kt. And sometimes instead of A, we use P for population. So you might see P of t equals P naught e to the kt. So let's talk about what these different pieces of the formula mean. We have that P naught, which is our initial population. And if you're using the formula with A, that would be A naught. The K is your growth or decay rate. So it's called a growth rate if your population is growing. And your value of K will be positive if your population is growing. And it's called decay rate if your population is getting smaller. And that value of K will be negative if your population is getting smaller. Then we have T, which is our time. And we can use any unit of time, months, days, years, whatever suits our problem. And then we have our P of t, and that's going to be the population after time. And that would be also, if you're using the A's, A of t. So that's going to be the amount you have after a certain period of time. So in order for us to answer this question, we really need the growth rate. We need the value of K to be able to answer this question about what will the population be 3 years from now. So we're going to be able to find the growth rate with just this piece of information in the beginning about the population doubling in size over 28 months. So the 28 months is a time, and the population doubling in size tells me the relationship between P naught and P. So P will be twice P naught for the population to double in size. So with that information, we're going to be able to substitute into the formula and solve for K, the growth rate. So let's do that. So we have our formula, P of t equals P naught e to the kt. And with just using this two pieces of information about 28 months and the population doubling, I would be able to substitute 2 times P naught in for P, leave P naught here, and substitute a 28 in for time. That was 28 months. The population doubled in size in 28 months. Then I can start solving by dividing both sides by P naught. And you can see that that P naught cancels out on both sides of the equation to give me 2 equals e to the 28k. Then I'll solve this exponential equation by taking the log of both sides. Then I can use the power rule, and the power rule allows me to move that power in front of the log to make this natural log 2 equals 28k natural log e. Natural log e is 1. And I'll divide both sides by 28 to get k equals natural log 2 over 28. Now, I could put that in my calculator to get the growth rate, but I don't want to do any rounding in this. Since k is going to be a decimal answer, and those decimals will go on forever. So I don't want to round at this point. I want to round at the end of the problem. So I'm going to leave k in its exact form, which is this natural log of 2 over 28. So let's go back to the question. And the question says, the current population is 40,000. What will the population be 3 years from now? So with my formula is P of t equals P naught e to the kt, but I was able to find what k was. That's natural log 2 over 28. So now when I'm using this formula, I have two variables. I have P naught, which is my initial population, and the time. And that's exactly what they gave me on this second part of the question. Their current population is 40,000. What will the population be 3 years from now? 40,000 is the initial population. 3 years from now is the time. So I'm going to use, for P naught, I'm going to use 40,000. And for the time, I have to be careful here because although I told you earlier, for time you can use any units, days, months, years. You can use any units, but you have to be consistent about whatever units you're using. So because we used 28 months earlier, we need to make sure the units for our time is months. So 3 years is the same thing as 36 months. So we got that by doing 3 times 12, the number of months in a year. So I can substitute 40,000 and a time of 36 months to find out what the population will be 3 years from now. So I'm going to put this in my calculator. It's 40,000 E. It's a little bit easier if I type the 36 first instead of last. Natural log 2 over 28. And that's 97,521, and I'll round to the nearest whole number. And I just want to make a quick correction just in case this confused anybody. This is natural log of 2 over 28. I didn't want anybody to think that 28 was inside the log. Okay, so after 3 years, our population grew from 40,000 to 97,521. Thank you for checking out my videos. Have a great day.